Okay, so we saw a lot of words go by in the first 45 minutes. Now let's start looking at some code. Okay. Where do I want to go from here? Let's take a look at the. Actually, let's take a look at how we build a project. So this project 0. When I first started the course, this was the first project that we did, and after a couple of years, students were like, "It's too easy. It's a lot like the first project, so we don't need to do it." I'm like, "You're right," but it is a good example of us getting started with a project. So, with a Java project. So in this little example project, we write a student class. So there's one class, and it's subclasses. Something that a class called human that I wrote. And if you watch the screencasts, you learn that human's part of this whole like animal hierarchy thing that I have. And really, what I hope to show you through this assignment is what it's like to work with someone else's code, and then how inheritance and virtual methods work, et cetera, and also how to read program arguments from the command line. I guess if you were doing it on your own, that's what you'd learn. What I'm going to use it for is to show you how to use tools like Maven, to use the IntelliJ IDE, and then I'm going to use it both tonight and tomorrow night to show you how to do test-driven development. Yes?
These are all covered in your videos, correct?
Sorry, what is all covered in the videos?
What we're going over right now.
These concepts? Well, I'm recording tonight's lecture, and you'll be able to watch this again, but I don't know if that answers your question or not.
When you live code, is that recorded?
Yes. Yeah, when I code for you guys. And sometimes I do it like at home, too, because I'll get home and it's like, oh, there's something I forgot to show them, and get like little bonus lectures and stuff. But yeah. But yes, so that's a good point. I guess I didn't make it, didn't stress it. So all of the slide content here, again, me speaking to the slides and what would traditionally be a lecture, all of that's up online and on YouTube, and that was recorded a couple of years ago. But as you probably noticed, I'm recording a lecture tonight, and what I'll do is I'll mix it down. I don't live stream it. Because sometimes the jokes go the wrong way. It's not something that I want my kids to be able to see or have the federal investigators be able to find later. So right there goes my bid for the Senate. I mix it all down and want to give myself the opportunity to cut it down, especially if there's like something goes weird in the middle or the audio is bad. That's happened sometimes too. So anyway, I'll mix it all down, and I usually get it posted within 24 hours of class being done. So yeah, you can go back and watch later. Right, and so that's if you miss class or if there's something that you want to review, you can do so. You're all adults, and we've all got lives outside of school, and sometimes you can't make class. Sometimes you don't want to make class, and I don't want you to be penalized because you get sick or you need to take home, be at home, take care of somebody in your family. So, and plus it's so easy for me to do now. So I can just make it all available to you. Okay. So in a moment we'll see that when you that we create a very simple class called student that extends human and it's got a constructor. We'll go into more details about all of this in a little bit. And there's some methods that you need to implement in order to in order to implement a main method that then is a little command line program for Java. So yeah.
Do we have to document or comment assembly?
Yes, you will. We'll be talking more about that in detail next time, though. Yeah, and you can look ahead. There's a documentation PDF out there, but yeah, that talks about sort of what the requirements are. And as we get into the course, we'll talk more about the pros and cons of documenting your code. Okay. This makes more sense when you read it. I'm going to go out of order because I want to show you guys some stuff. So there's a tool called Maven. It's an open source tool developed by the Apache guys and gals that is all about building Java projects. So as you probably learned, there's like the Java source code, and then you compile that into this bytecode thing, and then you run it on a Java virtual machine, right? That cycle's familiar to you guys, I hope. Yeah? and you probably learned about the command line tools for doing it, like Java C to compile it, and then did you learn command lines or do you guys use IDEs? Okay, command lines and both. Okay, so in your IDE, you just build your project. Great. But there's all the stuff that happens in the background. And I feel it's important to understand both. To have enough experience with the command line tools to know what they're doing, and then say, well, that's very nice. I never ever want to do that again because it's really awkward. And then use your tools, and so that when things go wrong, you understand sort of what's happening underneath the covers. With Java projects, as your project gets more complex, the build process often gets more complex. So, for instance, you write your source code, and probably when you first learned about Java, it was one file that contained one class, and maybe you had 3 or 4 at the end. Well, as your application gets more complex, you have a lot more code. It's distributed over more files. You can have different packages. You start using other people's code. So third-party libraries. You'll see in this course, you write your code, and it needs my code. I provide you some superclasses and stuff that you need to leverage. And so that all gets in there, and your build process gets more and more complex, right? So you need to tell, when you compile your code, not only is it compiling your own code, but you need to tell it what other libraries to use, what other jar files, all that stuff. And this is very complex. Add in things like you want to be able to unit test your code, and all of a sudden you've got yourself a project. There's a lot of stuff there. And what Maven does is it provides a number of tools and some standard conventions for specifying Java projects. And so then you can watch the lecture and get all the details and stuff. But this is a tool that you'll be using extensively in the course to sort of manage all of the pieces parts of your Java application. One thing that Maven provides is something called an archetype, which is like a prototype or a template project that helps you get started. You'll watch the Maven lecture and say, gosh, there's this big XML file you need to configure and all these directories that you need to create. And again, it's like, I want you to know that, and I want you to think about what it'd be like to experience and start from scratch. But this course is programming with Java. It's not configuring your Maven project with Java. So to help you get started, I've created these things called archetypes. And so you can see where to go get the Maven executables and install the tool and do all that stuff. So what I'm going to start with here, though, is a Maven command line that will generate a new project for your that will get you started with this student project here. Well, that'll get me project. We'll in a little while walk through the same procedure with your first project. Actually, first of all, do I have a student? Yeah. Okay. So I'll delete. Sorry, that other student project that I created, because I'll create a new one. Okay. So MVN is the script that runs Maven, and you say archetype generate, which says, well, generate a new project for me to work on from an archetype. And the way you identify the archetype that you use, because there are hundreds of them out there, is by the following. Every Maven generates these things called artifacts, and so artifact is like your built application. So it will, for your project, it will be what's called an executable jar file, a little, main method, a program with a main method that can run itself. And every artifact is something called a group ID, which basically identifies the people that created it. So in this case, it's edupdx-cs410j. Again, same for the graduate students. This is one of those things where it's like I bias towards the 410 because I don't want to invest the time to change everything. And then you'd say, here's the group that produced it, and then here's the name of the artifact. So in this case, it's student archetype. And so then, the first thing you'll do, according to the assignment, is enter this thing into, on the command line. So run it here, and Maven goes out. Oh, I found it in my little catalog. Sorry, I had a demo all set up, and it didn't do it for you. I'll go back and show you guys what I did later. Let's see here.
Is yours already set up?
Mine was already set up. There's an important configuration step that I wanted to show you what happens when you don't do it, because it's doubtful that most of you have done it. So then it's sort of a word to the wise. So let's see here, student archetype. And just blow that away. Okay, try this again. Maybe I'll edit that out. No, I won't. Okay, so it says, hey, go create me a new, oh, damn it. Downloading. Ah, yes, okay. Okay, well, this is approximately what it is. Oh, local catalog? Okay. Fine, I'll blow away my local catalog, which I think should be okay. Archetype catalog. Once more with feeling. Generating in active mode. Okay, great. I just told Maven to say, hey, create me a new project based on that student archetype template. And if you go and look in the output, way up here, oh gosh, Maven, seriously? You'll see that it said, hey, I couldn't find that template that you were looking for. No archetype defined, oh, sorry, specified archetype not found. I don't know why it warns you. It should just give you an error, but I suppose I could file an issue on GitHub for them to fix that. And so Maven, trying to be helpful, said, well, I couldn't find the archetype that you were looking for. Hey, maybe you meant one of these literally 1,800 other archetypes that are out there. Yeah, right. Sorry, 1,878. How about number 991? Okay, this isn't useful. And so, like, if you see this, Control C. This is not what you want. Instead, there's a very important piece of configuration that you need to do, and it's outlined here in the assignment. So there is the reason I couldn't find it is because Maven. One of the cool things about Maven is that there are repositories of artifacts in well-known locations on the internet that has basically all of the all this open source software and even some commercial software that's all out there. And we'll use these repositories extensively to get things like our unit testing framework and GWT and all of the Java servlet stuff and everything like that. But my stuff's not out there. My stuff's in a different place. And so what you need to do to get all of this to work is to edit what's called your settings XML file in your .m2 directory. So .m2 is Maven's configuration directory in your home directory. And so what you need to do is put a big XML file in that. So, oops, do I have an Emacs on this? Yeah, emacs.nw m2.settings.xml. Cool. Okay. And so anyway, so step one, cut and paste, copy and paste all this stuff out of the, come on, very slowly. Scroll, there we go. Out of the PDF document into here. It doesn't format it very nicely, but that's all right. As long as it's parsable, it's okay. And basically what this is saying is like, oh yeah, here's where Dave's stuff lives. And you're going to want that for this course. You need to have my stuff. So it basically says, hey, go look for libraries in my Maven repository, which is hosted up on Bintray. You can go, if you're really interested in learning more about this, you can go on the Maven website and learn all about settings.xml, but it's perfectly fine to just copy and paste it in here and get everything to work. So now that I've made that configuration, we'll try my Maven command again. Oh, please work this time. Oh, damn it. What didn't it like? Oh my god, that's awful. Beanstalk. Specified archetype not found. Huh. This worked on the... Oh, that might, no? Yes, that might do it. Probably can't set this one across multiple lines. We'll try that. Yeah, cut and paste from a PDF is always a bad idea. Damn it! What is wrong? Oh, I didn't need to do that. I already had it here. Huh. Anybody see anything funky going on here? Settings.xml. Oops. Kel embarrassing. This is the anyway. No, that's don't need a slash there. So you got to work on yours?
Yeah, I'm getting defined value for property group ID.
That's good. You're lucky. Sorry, I'm a little punchy.
You might have gotten the 2 in there. Did you? The first time I pasted in, I accidentally got the page number in there. You messed it up.
Pasted into Notepad.
Why are you so slow? Oh, I wonder if it's. Oh no, I've copied and pasted here before. Hopefully there aren't any like weird characters or anything. Ah, what was that? Copy, paste. Oh, that's messed up. Okay, interesting. So yeah, don't use text edit. Don't save. Oh, I could just plain text, couldn't I? So open home. Oh, of course, it's a hidden directory, right? Can't find it. Ah! Sorry, I gotta go back to the command line. We'll try VI. I wonder if it's Emacs. That seems unusual. Probably Emacs? No. Baby, you wouldn't do this to me, Emacs. I set this. Settings.xml. You might encounter similar problems, which is why I'm, let's see here, M2. Thank you. Huh. I am perplexed, and I'm using up valuable class time going through this nonsense. So, I guess one more thing I want to try. Huh, it doesn't complain about my... oops. Dash X. This is reading it and isn't complaining about it, so either it's not telling me something. Okay, enough of this. Luckily, I made a backup. I hope. Yep. Okay. So yeah. Copy Dave settings. I'm not going to show you this file because it has some things. Has some like passwords and stuff. Not passwords, but like hashes and stuff set in it that I don't want on the recording. So we'll try. Copy my old one to my current one. Yes. Okay. Archetype. Oh, no way. Damn it. Is
there a typo in your command?
That's possible. EDPX is for in J, archetype, artifact ID, student. I know let's try one more thing. Let's try oops. Let's it might be a problem with that one. I wonder if I can get the one from Project 1 to work. Ugh. Oops, where's the Maven archetype? Command, there it is. I don't know, that looks a lot like it. Oh, I know what it is. Okay, that's, damn you. Okay. So the I'm not gonna go into the details. You can Yeah, okay, so wait, what was the name of that? Org. Sorry. What's happening? Okay, so there's this kind of funny thing going on. I didn't used to have to do all this configuration, and it's only with the latest version of the of a particular of the Archetype plugin that this configuration is necessary. And it turns out I am using the old version of the Archetype plugin, and I want to use the new one. So I'm going to blow away the Maven Archetype plugin. rm-rf.m2 repository. So one of the what Maven does is downloads a whole bunch of stuff from the internet and puts something in your local repository. Excuse me. Org Apache Maven Maven. Sorry, it was Maven Archetype plugin. Plugins Maven Archetype plugin. Oh, it should have version 3. I wonder why does it use version 2.4? Yay, it's working now. Of course, I did it in the wrong directory. Never mind. Okay. Jeez. Okay. Let me know if any of you guys see that. Now, I mean, I've got all sorts of crazy stuff in my Maven repository and things like that. So, but you guys are working down here on front, and you're okay following the directions in the assignment? Seems to be okay. I'm getting a couple other thumbs up. Okay. Sorry, this is one of the things. You have these like nice, fresh, clean environments. Mine might be a little polluted on this one. Okay, sorry about wasting 10 minutes of class doing that. Okay, so pretend that never happened. Okay, so run this command. What this will do is this will go find find the template project, the Archetype out there. It'll download it. And okay, now it says, good, I found the Archetype. I want to create a new project for me. And so the group ID, I'm going to have my own group ID. So edupdxcs410j, because we're all in the same class, but mine is going to be Whitlock. So I'm pretending I'm one of you guys, and I'm creating one of these projects. And this sort of says, all my code will be in this part of this group. The artifact ID will be student. I'm not doing the airline here. Sorry. I want the student archetype. I am batting 400 tonight. Okay, edu pdx410j Whitlock. Artifact ID is student. Version 1.0 snapshot. Great. Let's take the default. The package is going to be the Java package that my source code is going to live in. Ask me to confirm. It's like, yes, create me one of these new projects that is one of these student projects and give it that information. Okay, and now what I have, it told me, okay, great. Project created from Archetype in directory student. So now here in my student directory, I've got a bunch of stuff. Sorry, I'll leave it at the top of the screen so more people can see it. There's something called the pom.xml, which is a big XML configuration file that we probably won't go into too much tonight. And then it has my source directory. This is all the stuff in my project. So I created these files, and I'm going to open them up in IntelliJ now. So now I'm going to go to IntelliJ, which I have open. And that's like, not for this. I'm going to open that project, which was in my PSU directory. Oh, here in student. I can click on the pom.xml. Pom is the thing that describes the Maven project. And you can watch the screencast and see all sorts of details there. When I open it, open as a project. Open it in a new window. I was expecting a little bit more. Oh, did I not do that right? I was expecting a little bit more. A little bit more of a workflow. Okay, so maybe you can't just open the POM. You might need to open up the directory that the project lives in. Oh bother. Okay, cool. That's looking more like it. Okay, good. So this is IntelliJ. Over here on the left. You have your navigation basically. And right now I have it set to navigate directories. You can also have it navigate just packages, but for these demonstration purposes, let's look at the files there. So when I used that archetype, it created all these files for me in certain directories, and these follow Maven's conventions for where your source code should live and where your test code should live. So remember back in the PDF, I talked about this this student class. Nope, not that one. The student class, yes, the thing we can read. How it has this constructor and everything like that. Well, that's right here in our student. So this is our student class. It is partially implemented. It has its constructor. Lots of things are hidden by default, or it collapsed. And it has some methods. It has a says method, which is supposed to say this class is too much work, but it's not implemented yet. Similarly for the toString. And then it has a main method. Now the main method is where the command line program is going to start, and the command line arguments are passed in to the main method in this array of strings right here called args. So this is sort of like the application code, this very simple student class. And there's also some tests that we'll look at in a minute, both what are called unit tests and also integration tests. Okay. The last 15 minutes have been really confusing to me, and I want to pause here for questions from you. Did anything of what I just said make sense? No, yes? Yes? So, let's quickly review. We used Maven. Maven's used for many things. The first thing we used Maven for was to create the beginnings of our project. And so great, now we've got the beginnings of our project, we've got some source code, and we've got some Java code, and we opened it up in IntelliJ so we can start editing it. We did that much. Okay. I want to go back to the command line to show you some of the things that you can do with Maven. So a Maven project has what are called different phases. So for instance, there's a phase where it's like, build my source code. And then there's another phase which is like, run the tests on my source code after I've rebuilt my source code. And then there's things like generate a bunch of documentation from all of my source code, build me a website, run a whole bunch of tools. It's all covered in the lectures, and we'll see some more stuff in the future. But I want to show you a couple of things that we can do now. This all comes from the assignment, I believe. Cool. To basically do end-to-end build and test on your application, use a command called Maven Verify. Maven Verify will do the following. It will compile all of your source code. It'll compile all your test code. It'll run your unit tests. It will build any artifacts that you have. And so this project builds what's called a jar file, which is basically a collection of compiled Java classes. And then it'll run what are called integration tests on it. And so I'll talk more about the difference between unit tests and integration tests later. But unit tests are meant to test small little things like a class or a certain method. Integration tests are larger things that essentially test your entire application, how well classes or different modules integrate with each other. So I ran it, and it did all of that stuff. So there's lots of output here, and I'll leave it to you guys to walk through all of it yourself. But I think a couple of things I want to point out is that here's the output of running the unit tests. So there's a class called student test, which we'll look at in a minute, that has one test in it, and it runs it. And then later on, it builds what's called the jar file. So you can see it's doing its jar thing right here. And then it runs the integration tests. And there's an integration test called student IT for integration test. And it runs it, and luckily there were no errors, and everything ran successfully. Maven puts, so in any build system, there is the source that's built, and then there are the outputs of the build, or the generated artifacts. So you guys probably learned about, there's like Java source code that gets compiled into a class file. Right? So the class file is not something that you write yourself, and is something that's generated by the compiler, and also something that can be blown away when you don't need it anymore, right? When you want to start over again. We'll see that in a second. But before that, and all of these artifacts are put in a directory called target in your Maven Maven build. And why do you think they're all put in the same directory? Why do you think everything that your project builds is put in the same directory? Yeah.
They're dependencies. They need to be able to find each other, I guess.
Oh yeah, there might be some of them that are required to be in the same directory, especially if you want to like maybe bundle them up. Yeah, that's a good answer. Wasn't one of the ones I was thinking of though, but yep.
Relative path names.
Relative path names might be another one. What I was thinking of though is that when you put all of your build artifacts in the same directory, it's really easy to blow them away because all you do is blow away the target directory. And that's important, right? I've worked with build systems in the past where it's like the compiled stuff is like all over the place, and so then the process for just cleaning up and starting over again, which is something you want to be able to do, right? You get your application to a funny state, or you want to make sure that if I just start from scratch, I'll be able to build it okay. Making sure that all works is important. So yeah, everything goes into target so that everything can be blown away really easily. But if you look what's in this target, you've got all sorts of stuff. You have your class files that are generated. You also have what are these reports? So let's see here. Target Surefire. Surefire is the thing that runs the unit tests, and so you've got this like little text file that you can look at to see which tests pass, et cetera, et cetera. And you've also got something called the jar file. Yes, question?
It's like why is there a maximum size? Is final memory 23 out of 204? As if to imply your disk is like capped at 204 megs.
Well, that's RAM. It's not disk, right?
Okay.
Yeah. So final memory. This is I don't know why Maven prints this out. My understanding is that this is the JVM's memory. So I don't know how much they go into like really what happens inside the Java virtual machine, but I will. The Java virtual machine provides the runtime environment for Java, and so services that for native applications are provided by the underlying operating system. Things like memory allocation, things like thread scheduling, stuff like that is all taken care of inside and security checks are all taken care of inside of the Java virtual machine. And this is nice, right? I mean, you guys have done native programming, and if you've ever, you know that in order to get like a C program to behave the same way on Windows and Linux and Mac OS, you need to have a lot of conditional code. They have different threading libraries. They have different APIs that you need to use underneath the covers. Some of that is abstracted into like the standard C libraries, but a lot of it isn't. Well, in Java, they move all that abstraction up one more level, saying, okay, the JVM itself knows how to do Java things on Linux, on Mac OS, on Windows. You, the Java programmer, don't need to worry about that. The people that develop the virtual machine worry all about that. So one of the things that the JVM does is it manages the memory used by your applications, right? You guys have learned about new and delete in C++ or malloc and free in C and stuff like that. All that memory management stuff, all that stuff that you can get seg faults because you don't do it right and stuff. Java takes care of all of that. But in order to provide all of those services, it needs to, the JVM keeps track of all the objects that you created, and then it has something called a garbage collector, right, that you've heard of, that goes through and takes care of all of that memory. Well, for whatever reason, the last thing that Maven prints out before it exits is, here's how much memory I used. I'm guessing at one point they had memory leak problems, or for big huge projects, people want to know, hey, how close am I to the cap on memory? Because I don't want to get out of memory error in the middle of my build, because that would be bad. So I think that's why they do it. But good observation. One of the things that's built by this project is something called a jar file. A jar file is a collection of compiled Java classes and maybe resources like files that contain display strings or icons or images or whatever your application needs to be your application, to do your application stuff. For this simple student application, what the jar file does is it contains all of the really just the student.class. I can take a look at it, I suppose. Oops. jar-tf and then target student snapshot.jar. Oh, all sorts of stuff. Oh, right. Eek has got a lot. So everything that your application needs is included in this jar file. And so even though there's only one piece of source code, the student.java, this this jar file actually contains a whole bunch of stuff because I've got because it contains not only the source code from the compiled source code from your application, but it also includes all of the libraries that it's dependent on, which includes the like the human class and everything that the human class needs. So there's actually a ton of stuff in here. What you need to be aware of is actually just this student class. That's what you'll use. But all this is taken care of for you by Maven because I want you to be able to quickly develop an interesting application and not just spend the first 2 weeks of the course figuring out how to use the Java C command line. I learned that the hard way the first couple of years I taught the course. It was really frustrating for everybody, especially the students. Okay, so Maven, until you watch the lecture, it can be magic, and that's fine. Maven creates all that stuff, and so now what you can do is you can run the command line from your student class by doing the following. You say Java, which will invoke the Java virtual machine and point it at the jar file that's created. And when you run that, it prints out missing command line arguments, which is exactly what your main method prints out. Missing command line arguments. And it did a system.exit1, and so then, come on, $? It returned, and it exited 1. So this is the command line portion of our program tonight. So this is what you can do in the command line. You build the project using Maven, and you can run the main method using Maven. I think that's all we'll deal with on the command line tonight. Let's go back to the IDE and take a look at what we're doing. Okay. In the IDE, you can edit your source code. Yeah, question? Yeah.
How did you open, or what did you open in IDEA to get it to have all your...
The directory, the student directory. Yeah, give that a try. Yeah, which is strange. I thought if you opened the POM, it would do the right thing, but apparently it didn't. Well, yeah, right. Yeah, so don't be like me. Open the directory instead. Okay. So here in the IDE, you can edit your source code, and you can also do things like run your tests. So let's take a look at the student test. Now, this is a test. We'll go into more detail on it maybe later tonight, but most likely next week. So a quick aside on unit testing. On unit testing. So when I was your age, when I first entered the profession, we were the common thinking was that there are two kinds of people that work in software development. There are developers and there are testers. And the developers, what they do is they write the code, and then it's someone else's job to make sure that they wrote the correct code. And this sort of made sense in kind of like a we're working in a factory, and I'm at my station, I make my piece, and I make it, and I'm at a different station, and I make my piece. But what it resulted in is very long feedback loops. And I remember experiencing this as a newly minted engineer, where it's like I would write a piece of code, and I thought it did the right thing, and I maybe poked it a little bit and tested it. But then a couple weeks later, someone would test it, and they're like, "Oh, hey, this is busted." And I'm like, "Oh yeah, right, that's busted. Where was that implemented again? What did I do 2 weeks ago?" And it was awful, right? Because no one was happy. I wasn't happy that I had to go remember a bunch of decisions that I made 2 weeks ago, and the person who tested my code wasn't happy because they had to wait for me to find this out. And so one of the things that people that were on the forefront at the time were realizing was that if you can make that feedback loop faster, you'll develop software quicker. Right, it'll be done sooner, and so what came out of that was this idea of having the same person that write the code write an automated test for it, write a small little automated test. And what you test is not at the macro level, but at the micro level. So I'm writing a method. I'm going to write a test to make sure that method behaves as I expected. And this is cool, because you can express that test in Java code just like you express the functionality under test. And so in the Java world, Kent Beck and others created this very simple test framework called JUnit, so Java unit testing. And basically what you do is that you have a class whose name ends in test. And there's a Java class that has methods, and each method executes some test. And you put this @test annotation on it to say, okay, this is a test. So let's just take a look at what this is doing real quick. It's a very simple test. It's basically saying, hey, a student that's named Pat is named Pat, right? And so I create a new student object, and I give it a name of Pat. And so this is the student, this is the constructor for the student, the thing that I'm testing. And I create that object, and then there's also this. There's also a library that provides these very expressive ways of validating your test. So really any test, but especially unit tests, have three parts. There's the given, the when, and the then. So you start out with the given. So okay, for this test, what do I know to be true, or what is the environment, the situation the test is running in? In this case, the given is, okay, I've got a student named Pat. So given I have a student named Pat, when I do something, so in this case, it's when I do something, then I expect something to happen. So what I'm saying here is that I'm going to assert something that I expect to be true when the test, and for the test to pass. That I assert that, hey, when I call getName on this Pat student I just created, it will be equal to, the value returned by getName will be equal to, well, the name that I passed in. This is a very simple example of like the unit testing pattern. I'm not testing very much, right? It's 3 lines of code here, right? It's very simple stuff, but what I'm doing is I'm using these micro tests to then build up a larger suite that's exercising all the functionality that I add, and that'll give me confidence that, well, my code does what it's supposed to do, does what I expect. So it's all about checking your expectations. When you don't, your expectations become assumptions, right? Understand the difference between the two? Right? Expect, and it's something that I expect to have happen, and I can verify it, is much more powerful than it's like, well, I must have written it right because I'm an excellent developer. Well, you know, one of the things I learned along the way is that I'm not always right. And so then, but if I can prove that I'm right by writing unit tests, you know I did it right, I know it behaves the way I expected it to. So anyway, that's what I'm expressing here in this source code. And inside IntelliJ, it lets you run the test. So if you click on this little button here, or there's a keyboard shortcut also, you can run this one test method. Cool. And it says student name Pat is Pat. Everything everything passed right here. So this is a unit test. Later on in class, we'll watch a video that introduces the concept of test-driven development, where instead of writing your tests after you've written the code, you start with the tests. And when I discovered this and we really started doing it, I realized this was so powerful for me. And I'll explain why after you guys have had a chance to see it. Anyway, so for this application, it comes in multiple parts. There is the code that is the application code, this little student program that has the main method and it has the constructors and the other code that supports it. And then there is this unit test right here that, that exercises that code. Any questions? What questions do you have? There must be some out there. What if this was familiar to you? Oh, sorry, you had a question, yeah.
JUnit?
Yep, JUnit.
Does JUnit have a way to run the same test multiple times with different variables?
It does. I don't have a good example of it, and honestly, it's not a piece of function I'm terribly familiar with, but there's good documentation on JUnit. And so, yes, so let's say that you have, you want to have the same test, like test procedure, but you want to have different inputs to it. Yes, you can do it that way. And actually, it's a very powerful way of like running lots of permutations and combinations of inputs into your program and making sure it does all the right stuff. Great question. Okay, since it's time for another break, let's take another let's take 10 minutes and be back at 7:42.